Hello YouTube, RJ. Today's video is all about your handheld antennas. Now there's a legend out there, if you want to call it that, in ham radio that the first thing you need to do when you buy an HT radio is take your rubber ducky and throw it away. Is that true? I don't know. We're going to find out. We're going to do some testing. I'm going to build my own HT antenna, and then I'm going to start comparing it to other antennas, the stock antennas compared to what I built. And we're going to see what the difference is between, say, a rubber ducky and a quarter wave antenna is. What do you really gain from it? Is it worth it? Do you need to do it? What's the benefits? What is the cons of doing it? And we're going to find some interesting facts out today. So stay tuned to the end. See which one of these comes out best. Let's get into it. Okay, here we are at the computer. And as you can see, I've got my Nano VNA Saver software loaded up on the computer. And you can see in this picture here, my Nano VNA is hooked up to some kind of contraption there. It looks like it's a piece of the leftover moon rover lander, whatever. And what it is, it's a piece of cardboard with copper tape on it. And the purpose of that is it's not big enough to be a good ground plane for 2 meters and 440, but it's kind of representing the poor ground plane we have when you're relying on the radio chassis and your arm and your hand to be the ground plane. And this is not going to be a test that's going to be precision accuracy as far as calibration. What it's going to be is it's going to be a comparison between different antennas. We're going to look at the SWR at 2 meters and 70 centimeters across a number of antennas, comparing the antennas under the same circumstances. So that's what this is. So the first thing we're going to do is I'm going to jump over here and I'm going to connect to the device. It should connect up to my VNA, which it did. And we need to do a calibration, so you'll get to watch me do that real quick. I'm going to go ahead and use the assistant. And it wants me to put the short. So let me grab the short and put on. I'm going to, sorry about my squeaky chair if it squeaks a bunch, but the purpose here is we got to get the VNA to calibrate all the cables and fittings and everything off. So we're going to put the short there. And then it's going to have us change that out for the open. So we're going to do that. And I've converted everything to BNC to make my life easier. So now I'm going to put the open on. And we're going to calibrate that. And it's going to want the 50 ohm load. So we're going to remove this one. And we're going to install the 50 ohm reference. And we'll tell it it's on. And then we're going to say, okay, we're happy with that. We're ready to go. What I'm going to do here is I'm going to reach over and take this BNC connector off. And with that, we're ready to start looking at antennas. We're going to look at a number of antennas, but we're going to start out with the rubber duckies that come with the radio. So let's take a look at my Yaesu first. Here's the Yaesu. So there's my Yaesu rubber ducky, and let's do a sweep. And what are we going to look at here frequency wise? Let's look at about 130 megahertz through, say, let's do 460. Yeah, we'll do 130 to 460. And let's take 10 segments so we get a nice smooth instead of a lot of choppy few points. Let's give us quite a few more points. And let's sweep this. Okay, now let's see how we're doing on what we're interested in. So let's take a look at 146, the middle of the 2 meter with marker 1. Marker 2, we're going to take a look at 448. That's going to be about in the middle roughly of where you're going to need your handheld in the 440 for the repeaters and simplex. And then just for kicks here, we'll put this to 144, the very beginning of the 2 meter, to see how we come out there. Okay, and we look here, and on 146 we've got a 3.253 to 1 SWR. And then if we look at the 440, we're 1.298, so we're pretty darn good on the 440 band. And if we look down here at 2, we're pretty flat down here. This looks really good for 440. The 2 meter band, at 146 in the middle of the band, we're about 3.253. At the very beginning of the band, we're pretty good, 1.298, but it's a pretty steep climb here. So by the time you're going to get up to, let's say that we get up to 148. Let's see what 148 looks like. So 148 would be about 7.2 to 1 SWR. So you've got a real swing here on 2 meter. Not too bad at 146. Pretty nasty when you get up to 148. Interesting how steep part of the slope we are in here. Down here looks really good. So that's where we are. Let's turn around and try the Bofang. So if I remove the Yaesu and I put the Bofang on, let's see what happens if we sweep this one. Okay, so at 146, we're 3.759. At 448, roughly, what it's doing is there's only so many points in here, so it can't exactly go what I asked for. It goes to the closest. It's a pretty well flat 3 to 1. And 147 is 3.1. So as you go up in frequency, you're getting better, but unfortunately that means if you're going down in frequency, if we were to go look at 144 here, we're going to be worse. So we'd be 4.652. So not too bad. I mean, we're getting towards 4, but you know, if you stay in the 3 range on HT, we're probably going to be in good shape. That's not going to be too bad. So when you start getting these 4.5, 5, 6, that you're really putting a hurt on yourself. Ideally 1 to 1 is great, but it's going to be hard pressed to do that on a handheld antenna. So now let's jump into another antenna. Next antenna we're going to do is a well-known one, actually a very liked antenna, called a signal stick. And I ordered my signal stick and received it for the very reason of doing some testing and trying it out. And sometimes I have to have a little help here because I can't really get a hold of the knurled part down there to keep it from turning while I'm taking the antenna off. So it could be a challenge. So the signal stick, it's a very, very popular antenna. Many people swear by it. I bought one from them just to try out, see what I thought for some comparisons. And let's do a sweep of the signal stick, see what we get. Okay. This one's interesting. 146, we're getting about 5, almost 5.5. That's pretty high. That's in the 2 meter band. At the bottom of the 2 meter, we're getting 5.8. Let's see what we get at the top of the 2 meter. At the top, we get 4.7. So we're pushing 5 all the way up to, you know, well above 5.5 on the 2 meter. That's not that great. I'm not that wild about that. That seems like way too much SWR. I realize variables will, you know, it may be better than that with a better ground plane. You may put it on your radio and actually be getting better than that. But this is all comparison. So I mean, we're not looking for a fixed amount, a certain amount. What we're looking for is a comparison of how they compare to each other. So this is pretty high compared to the other antennas so far. 1.776 is pretty good down here. It's on a pretty steep run here. So let's take a quick look at the extremes of that just to cover ourselves. So let's say 440. That's basically 2.5. And let's go 450. And that's 1.5. So that's very good. It works very well in the 440 band, the 70 centimeters. SWR is looking a little harsh on the 2 meters. Okay, we've got one more antenna I want to compare. This antenna is my own design. This antenna is made much like a signal stick. The big difference is, I don't know if you can see in the camera, but it's a little longer. I targeted a little bit longer on it. What I've done is I've tried to create an antenna with the with the memory wire that can be bent and all the things and be durable and all. And, you know, with a little ball to protect your eye so you don't poke your eye out with it. And it glows in the dark also. That's very helpful. But this antenna, I tried to target a little bit in the middle. So let's see how we did here. Let's sweep this. We're going to call this the Lynx Flex antenna. Okay, how'd it come out? Well, looks like at 146, we're 2.449. So getting close to 2.5. I'm comfortable with that. Looks like at 448, we're a little bit higher than this. We're 3.681, but still comfortable. So let's look at, let's go back and look at our extremes on the bands and see where we end up. So let's go 144. We're 2.696, so basically 2.7 there. What about 148? Let's see where we are there. We're 2.151 on 148, so that's really good. So let's go up and take a look at the 440 side of things. Let's start out at 440. We're 3.137 at 440. And at 450, we're 3.823. So in my mind, this is a nice compromise. This is keeping the SWR within a reasonable range. So what does that mean? Does that mean that the antenna I created is better? Well, we don't really know. The SWR, in my opinion, is better looking comparatively. So how could we test and decide absolutely which one of these antennas performs better? Well, how about we put them in real world condition and really try them? How about we hook up some equipment, and what I can do is I can put up a transmitter, a fixed transmitter with a fixed antenna at a fixed location from a device designed to read RF and give us very accurate signal levels. And we can try each antenna on it to see which one receives the best. What I can do is I can convert the readout, which of course will be in minus dBm. I can convert that to maybe microwatts so that it's a positive reading scale and it's easier to see higher is better instead of the other way around, which makes it somewhat confusing. And then what we can do is have a separate test, put them all together on one chart maybe, where we do the opposite. We put a fixed antenna on the receiving device that's measuring our signal levels, and we go use a fixed transmitter and we swap the antennas out to see which one puts out more signal and put it all together in a chart, and we'll take a look at it. And so that's exactly what I'm going to do. We should be able to put some data together and kind of see, and then we can compare them to the SWRs and see if the SWRs really relate to the signal strengths you receive and transmit with these antennas, which would be an interesting way to say, compare SWR to say, does SWR have an effect on my receiving? Does SWR show a pattern of having an effect on my transmitting signal? I had intended to do this as one video, but as I got started, I could see that there's no way that I could fit all of this content into one video. So we're going to be 2 videos with this. So make sure you tune in to the next video where we'll take this SWR information and then we'll plot out the signal information from our next video, and we'll see how it all goes together. So thanks for tuning in. Appreciate you being here. Hope you enjoyed the information, and I hope to see you in the next video.